Welcome pre-cal students to the homework help video. Here's the assignment in front of you. Let's go ahead and get started. Number 73, 75, and 77, you are proving these are inverse functions by using composition of functions. So first of all, we'll do f of f inverse of x. And it's a -1 right there. And here we go. We take your f function, and everywhere there's an x, we're going to put a parentheses. And then we take this equation over here and we substitute it in to the parentheses. There we go. And then 7 over 8 times 8 over 7. Your 8's would cancel, your 7's would cancel. Left with 1x or just x. Okay? And now, of course, we have to do it both directions. So now we're going to take f inverse of f of x. So we take our f inverse function. Everywhere there's an x, we're going to put a parentheses. And then we substitute into the parentheses your f function, which is 7/8 x. Your 7's cancel, your 8's cancel, and you're left with 1x, which is x. And of course, that was your goal, to get x out of both compositions. Since that is what happened, then we know these two functions are inverses of each other. Okay, let's go ahead and do this again. Now we're going to take f of f inverse of x. So we take our f function. Everywhere there's an x, I'm going to put a parentheses. And now in these parentheses, I will substitute the f inverse function. Okay, for my numerator, I want to get a common denominator, and of course this number 1 right here, really, a common denominator, if you have a 1 here, really instead of putting a 1, I could just put x plus 1 over x plus 1, because anything over itself is just 1. And why would I use x plus 1? Because my denominator here is x plus 1. And so now I have a common denominator, and so putting these two fractions together, I have x plus 1 minus 1. So that's just x all over your common denominator of x plus 1. And that's all over your other fraction, 1 over x plus 1. Now, we're going to take this bottom fraction, we're going to flip it and multiply it times the top. So there, notice I have taken this fraction here and I have flipped it, and I'm going to multiply it times the top. Your x's would cancel, and let's see, I did write one thing that was incorrect, and I apologize. This should be a 1 right here. There we go. So these would cancel here, and you're left with x times 1 over 1, which is just x. And now we have to do the composition going the other direction. So now we're going to take f inverse of f of x, and we take our inverse function, and everywhere there's an x, I'm going to put a parentheses. And now I'm going to substitute my inverse, or my f function, in, which is 1 minus x over x. Now, in my denominator here, right here, my big denominator, I want to get a common denominator for these two expressions. So for 1 right here, really for the number 1, anything over itself is just 1. So instead of putting the number 1 there, I'll put x over x. And why did I pick x? Well, my denominator here is x, and I want to have an x here, so x over x gives me a common denominator. Now I have 1 minus x plus x. Your x's will cancel, leaving you with 1 over x. So really I have my top here, which is 1 times, and then I flip this fraction and I multiply x over 1. And 1 times x over 1 is just x. So there we go. I took the composition going both ways, and I got out x both times. Now number 77. I will very quickly take my my f function, and everywhere there is an x, I will put a parentheses. And then I will substitute this into the parentheses. There we go. Multiply these two fractions together. Here my 2 would cancel with my 2. And here you can definitely cancel a 5 because both of these terms have a 5. So 5 goes into 5 once, 5 goes into 5 once, and 5 goes into 5 once. So you're really left with 1 times x plus 1 over 1. So we really have x plus 1. And I tell you what, I did make one little mistake here, and I apologize. I just caught it. When I made this substitution, notice this minus sign right here, and I put a positive sign. So there we go, all over 2. Okay, now your 2's would cancel, and then your 5 would go into your 5 here once, leaving you with 1x, and your 5 would go into 5 here, negative 1. So you're left with 1 times x minus 1 over 1. So you really have x minus 1 plus 1, which is just x. Okay? Now, we take this function here, and everywhere there's an x, we put a parentheses. And then in that parentheses, we will substitute this equation right here. So now we have 2/5 x plus 1. So take this 5 and multiply it through, and you're left with 2x plus 5 minus 5 all over 2. And of course your 5's would cancel, leaving you with 2x over 2, and your 2's would cancel, leaving you with x. So we took the composition going both ways, and we got out x both times. And so definitely we have inverse functions. Okay, now let's move on to our exponential expressions. First of all, on this number here, number 1, they just simply wanted you to get used to using your E button on your calculator, and if you type this into your calculator correctly, you will get 54.598150003. I just rounded 3 decimal places. Okay, if you have a graphing calculator, the button should be the third one from the bottom on the left side, and you will hit shift and then natural log, and this should pop up on your screen, E with an arrow and then an X, and then you type the number 4, close the parentheses, and hit enter. Okay, let's try another one here. Here we're going to type e to the negative 2.458, and if you do that correctly, you will get this right here, 0.0856059919. Okay, so hopefully you're typing these in correctly. If you're not getting the right answer, make sure you really work on this until you figure out how to type it into your calculator. Okay, now the rest of the problems will be graphing problems, so here we go. Let's go ahead and graph this function right here. First of all, I've taught you to find the horizontal asymptote first. You're looking for a constant term. You do not have one, so we can assume it's plus 0. So we have a horizontal asymptote at 0. Next, I've taught you to take the exponent, which is x, set it equal to 0, and solve. So x equals 0. And of course, you cannot solve that. It's already solved. So 0 will be your middle value on your table of values. And what I taught you to do next was write a table of values with 5 ordered pairs. 0 going in the middle, then we'll go up 1, 2, then we'll go down -1, -2. And here we go. 0 would give you out a 1, 1 would give you out a 6, 0 would give you out a 1, and I'm not sure why I put the 1 here. 2, 6 to the second power would be 36, -1 would be 1/6, and -2 would be 1/36. So here we go. If you go over to 2, you're way up here at 36. If you go over to 1, you're up here at 6. 0 would be at 1, -1 would be here, -2 here. So hopefully you can see pretty much the form of this graph, and all of these exponentials are going to be curves like this. They're really predictable. Okay, they're very predictable, and they will not cross the horizontal asymptotes. Okay, all right, moving on to number 17. Now notice there's no constant term, so I'm going to assume it's plus 0, and so right away I can see that my horizontal asymptote will be at 0 right here. Okay, next I'm going to take the exponent and set it equal to 0, and there's no solving to do. It's already solved for me, and so 0 will go, sorry about that guys, my pen is giving me some problems here. Your 0 will go right in the middle of your table of values, and then we'll go to 1, 2, -1, and -2. And here we go. Now be careful. Notice number 17 is not like this. It is not -2 in parentheses to the x power, okay? It is 2 to the x power, and then whatever you get out, you put a negative sign with it. So if I put a 2 in for x, 2 to the second power is 4. There's a negative sign there, so -4. Put a 1 in, 2 to the 1 power is 2. That's a -2. Put a 0 in for x, and you get out 1, but there's a negative sign there, so -1. Put a -1 in, that's going to give you a -1/2, and put a -2 in, and you will get a -1/4. So let me quickly plot those points. At 2, we are down to -4. 1, we're at -2. 0, we're at -1. -1, we're at a half. -2, we're at a quarter. So it looks like to me the graph's going to pretty much do the usual and curve up here and get closer and closer to the asymptote. Okay, so there we go. These are not too difficult. Let's move on to number 21. Okay, number 21, let's take a look at this. First of all, I do have a constant term all by itself, and there it is. So I know my vertical asymptote, or excuse me, my horizontal asymptote will be at 1 because my constant term is 1. So there we go. And then we take our exponent, which is -x, and we set it equal to 0, and we solve. So we divide both sides by a -1, and we still get x equals 0. So for my table of values, 0 will be right in the middle. Now, I will not take a lot of time and type these in for you. They're pretty much calculator problems. But if you have a graphing calculator like I do, I have already typed this into my calculator. If you hit your y equals button on your graphing calculator and then hit 1 plus, then hit your E button, and this will pop up, and then hit -x. Be sure and put parentheses here, parentheses, -x, and then close your parentheses. That's exactly what you want to have right there, okay? And now go to your table of values, and we have, let's see, 2 gives me out 1.1. 1 gives me out 1.4. 0 gives me out a 2. -1 is 3.7. And -2 is 8.4. All right? And if you don't have a graphing calculator, that's fine. Just go ahead and type these in one at a time. You should get these numbers out, okay? So we're over at 2, and we're up 1.1. Sorry guys, my pen is malfunctioning again. Okay, we'll use the mouse then. We'll see if that works. Okay, go over to 2 and up 1.1, then go over 1, up 1.4, and then 0 would be here at 2, and then -1 would be 3.7, and then -2 would be way up here somewhere at 8.4. All right, so let's go ahead and see if we can't get the curve here. Again, my pen's not working very well, so I apologize. Should come down and curve right here and right up here, and there we go. Moving on, number 25. Okay, number 25. First of all, we are going to notice we have a constant term here of +1, and so I know my horizontal asymptote is going to be at +1. That's the first thing you want to take care of. Next, you're going to take the the exponent, which is -x, set it equal to 0. Divide both sides by -1, and x still equals 0. So now we're going to put 0 right in the middle of our table of values here. We'll go up 1, 2, go down -1, -2. Okay, if we've typed this into our calculator correctly, we should get 0.86 out for 2. We should get 0.63 out for 1. 0.63. 0 has an output of 0. Negative 1 has an output of negative 1.7. And negative 2 has an output of negative 6.3. All right, let's see what happens here. Here we go. We're going to go over 2 and then up 0.8. 1 will be 0.6. 0 will be 0. Negative 1 will be negative 1.7. And negative 2 will be way down here at negative 6.3. So there we go. Typical standard exponential curve. Getting closer and closer to the horizontal asymptote, but never intersecting it. All right, number 29. Notice your constant term is a negative 3, so I know I'm going to have a horizontal asymptote at negative 3. Next, I'm going to take my exponent, which is x. I'm going to set it equal to 0 and solve. And of course, I get x equals 0. And so next, we're going to draw our table of values. And we'll put 0 right in the middle. Then we'll go up 1, 2, down negative 1, down negative 2. All right? Now, if you've typed this equation into your graphing calculator correctly, for 2 you will get out a 1. For 1 you will get out negative 1. For 0, you will get out a negative 2. And for negative 1, we'll get out a negative 2.5. And again, guys, I'm sorry, my pen is really messing up today. I'm not sure what the problem is. And then negative 2.75, okay? And so I do know how to write. This pen is just not working correctly, so I do apologize. All right, 2.75, all right? Let's see what happens here. Go over 2 and up 1. 1 is negative 1. 0 is negative 2. Negative 1 is negative 2.5. Negative 2 is negative 2.75. So hopefully you see the form of this. And there we go. All right. Let's go ahead and move on now to number 33. All right. But that is the basic gist of what the graph will look like. All right. Okay, let's continue on to number 33. Okay, first of all, we notice there is no constant term, so we can really put plus 0 if we want to. And so our horizontal asymptote will be right here at 0. All right. Now, next we take our exponent, which is x minus 1, and we set it equal to 0, and we solve. And when we do that, we come up with x equals 1. And now, for my table of values, I will put 1 right in the middle. So if I have a 1 here, I'll go up to 2 and 3. And if I have a 1, I will go down to a 0 and a negative 1. All right. Now, if we've typed this into our graphing calculators correctly, 3 will give me out a 2.25. And I will try to use the mouse. I think the mouse will be better. 2.25. And the number 2 will give me out 1.5. And the number 1 will give me out a 1. 0 will be 0.7. Of course, that's rounded. And then negative 1 will give me out 0.4. Okay, so here we go very quickly. Let's go over to 3. 1, 2, 3. And up 2 1/4, 2.25. Then we'll go over 2 and we'll go up 1.5. Then we'll go to 1 and we'll go to 1. And then 0 is 0.7. And then negative 1 is 0.4. So you can kind of see hopefully see the curve taking place there. This one's not as abrupt as some of the others, but the curve is still there. And again, I'm using a mouse to draw this, so that's why it's a little rough looking, but there we go. All right, so we're doing pretty good. These are really not too difficult as long as you'll follow the 3 steps that I've given you. So just 2 more problems to go and we will be finished. So here we go. Let's take a look now at number 37. Notice there is no constant term, so I'm going to put plus 0. And so I know I have a horizontal asymptote at 0. Okay? And then I take my exponent, set it equal to 0. 2x equals 0. Divide both sides by 2. And if you divide both sides by 2, you do get 0. And so now for my table of values, I will have 0 right in the middle. So if I put a 0 right here, then I'll go up to 1, up to 2, and then I'll go down -1 and -2. And if I've typed this into my graphing calculator correctly, 2 would give me out something pretty large. I'm going to round it to 55. 1 would be 7.3 or 7.4. 0 has an output of 1. -1 has an output of 0.13. And -2 has an output of 0.02. So we go over 2, way up to 55, go over 1, we'll go up to about 7.4, go over 0, that's at 1, -1 is at -0.1, and then -2 is 0.02. Okay, so you can tell this is one of these graphs that shoots up very quickly. I mean, 2 is all the way up to positive 55, so it shoots up very quickly and it bottoms out very quickly too. All right, so there we go. And then last but not least, number 41. All right, number 41. Now, before we get into 41, I do want to say you would first want to simplify this, and you would want to multiply the 2 through. So 2 times 1 is 2. Now be careful when you do your multiplying here. 2 times a base and the power is going to look like this. -2, and then your e here is still to the -x power. Okay, so the negative sign here does not go with the e. It's 2 times 1 is 2, and then pretend there's a 1 right here. 2 times -1 is -2, and then e is your base to the -x power. Now, having done that simplification, we can see we have a constant term of 2, so I know that I'm going to have a horizontal asymptote at 2. Okay? And then if you take your exponent, which is -x, set it equal to 0 and solve, you will get x equals 0. So in your table of values, 0 will go right in the middle. So 0 here will go up to 1 and 2, and then we'll go down to -1 and -2. Looking at my table of values here very quickly, -2 is giving me out a -13. I rounded that. -1 is a -3.4. 0 would give you out a 0. And 1 is going to give you a 1.3, and 2 will give you 1.7. So here we go. We will go over 2 and up 1.7. We will go over 1 and go up 1.3. 0 is 0. -1 is at -3.4, and then -2 is way down here at 13 somewhere. So you can see the basic curve coming up here, hitting here, turning this way, and then of course it shoots down very quickly too, like this. Okay, so there we go. I hope this has been a help to you. That's the homework help video for the graphing problems, also for the proving that inverse functions are inverses by using composition. Call or email if you have any questions.